Okay, now that I'm playing with modulus a lot in the functions, let us also try to look at another type of function. Again, similar to the previous function, because we're looking at modulus value. What was happening in the previous function? In the previous function, what I was trying to do was, I was trying to look at fx, and then we were trying to figure out what happens to f of modulus x. Now my question is, okay, here instead of mod x, what we take is the modulus of the whole function. So I'm trying to figure out what happens to modulus fx. What will be the graph of modulus fx? So just think about it. Y equals to modulus fx. Of course, it's a transformation coming from y equals to fx. Now I'm looking at modulus fx. Okay. Now I'm looking at modulus fx. So my y values that ultimately I want to look at are all positive. That's the meaning of it. Okay. My y values that I want to look at should always be positive. They will come out to be positive. X in the domain might be negative, but the functional value y that equals to modulus fx needs to be always positive. Okay, will be always positive. That's why I want to look at y equals to modulus fx. Okay, let's take a very simple example, something that we always know, log x. Log x graph, you are familiar with it, I am familiar with it, right? So let us look at y equals to log x, and the transformation that we will look at it will be modulus of log x. Modulus of log x. Now log x graph, as we all know, moves like what? And I've done in a previous video, in case you want to clarify your doubts, you can see that modulus graph looks like this. Okay, mod 0 is 1, so log 0 is 1, so it cuts the x-axis where? At 1, and the graph moves like this. Okay, moves like this. The bigger values for x, bigger the x, the bigger the log value. Okay, so it moves like this. Okay, you can even have negative, log, so it goes from negative y to positive y. So now what will happen to the transformation where I'm looking at mod of log x? What we are trying to say is that for the same negative value of y, we got to make it positive. For the same negative value y, we got to make it positive. So what will happen? You will have a mirror image of the portion below the x-axis of the graph. Okay, you will have the mirror image above the graph for the modulus function. So mod log x will have all positive y's. We cannot have any negative y. So in case I had any negative y, say I had minus half as a value of log, that will turn into half. Okay, by taking modulus, it will turn into half. So I will have a replica, a mirror image of half out here. Okay, the negative will become positive. So you will have a graph something of this sort. This portion remains same. This portion remains same. The portion that changes is below the graph of, below the x-axis. The values below the x-axis of y become all positive, and it will give a mirror image. So the graph will look something of this sort. So understand here one thing, that all your y's will turn positive by taking the modulus function. All your y's will turn positive by taking the modulus function. Okay, so that's the transformation y equals to mod fx. That's how it's gonna run.